25,300,000,000 kilometers. That is not a typo. That is not science fiction. That is the distance right now between you, sitting wherever you are, and a machine the size of a small car built in 1977, powered by a chunk of decaying plutonium, running on less computing power than the key fob for your car. It is out there, alone, in the dark, in the coal that has no bottom. It has no engine pushing it forward anymore. It hasn't for almost 50 years. It is coasting, purely coasting, on the momentum of a single gravity slingshot around Jupiter and Saturn, back when Jimmy Carter was president, and the first Star Wars film was still in theaters. And yet, this week, in 2026, it is still talking to us. Its name is Voyager 1, and it just did something almost impossible to comprehend. It sent us a signal from a region of space so remote, so alien, that human beings have no lived reference for it. Not from orbit, not from the moon, not from Mars, from interstellar space, the void between stars, where our sun is nothing but one more point of light in the rearview mirror. This is not the story of a satellite. This is the story of humanity's furthest reach, a 50-year-old survivor dying. By degrees, watts by watts, instrument by instrument, and still, against every expectation of the engineers who built it, refusing to go, silent. By the end of this year, Voyager 1 will cross a threshold no human-made object has ever crossed before. And what it's telling us, in its final chapters, might be the most important thing it has said since it left Earth. This is the story of a machine at the edge of everything. And the last transmission that could define how it's remembered. Let's go. Right now, in interstellar space, Voyager 1 is moving away from us at roughly 17 kilometers per second. That's over 61,000 kilometers every hour. It doesn't stop. It doesn't slow down. There is no friction out there to fight it, no atmosphere to drag against it, just empty space and the ghost of momentum from a maneuver. Executed decades ago. As of today, the spacecraft sits more than 25.3 billion kilometers from Earth. Over 170 times the distance between Earth and the Sun. To call that far almost undersells it. Light itself, the fastest thing in the universe, the thing that crosses from the Sun to your eyeball in 8 minutes, takes over 23 hours to reach Voyager 1. Every command NASA sends takes nearly a full day to arrive. Every reply takes another day to come back. A single, "Hello, are you still there?" From Earth is a 2-day round trip. And here's the part that should stop you cold. On November 18, 2026, Voyager 1 is projected to cross a distance of 1 full light day from Earth. 16 billion miles, roughly 25.9 billion kilometers. It will be the first human-made object in history to sit that far from home. A signal leaving Earth. That day will need a full 24 hours at the speed of light just to catch up with it. No probe, no satellite, nothing built by human hands has ever stood at that kind of distance and still talked back. This isn't a spacecraft anymore, not in the way we normally think about spacecraft. It's a message in a bottle that we can still, somehow, get a reply from. So how is it still transmitting? Voyager 1 left Earth on September 5th, 1977, along with its twin Voyager 2, which launched just over 2 weeks earlier. The mission, on paper, was supposed to last 5 years. A grand tour past Jupiter and Saturn, using a rare planetary alignment that only happens once every 176 years to slingshot from world to world using nothing but gravity. It photographed Jupiter's storms up close for the first time. It found active volcanoes erupting on Jupiter's moon Io. It captured the intricate, braided rings of Saturn in detail no one had ever seen. It found new moons hiding in plain sight. Then it kept going. Voyager 1's trajectory sent it up and out of the plane of the planets, away from the ecliptic, climbing toward interstellar space at an angle. On August 25th, 2012, 35 years after launch, Voyager 1 became the first human-made object to officially cross the heliopause, the boundary where the sun's solar wind finally loses its fight against the pressure of the wider galaxy. Past that line, you are no longer in the solar system in any meaningful sense. You are in the space between stars, interstellar space. Its twin, Voyager 2, would follow it across that same boundary 6 years later, taking a slightly different route and confirming what Voyager 1 had found. The edge of the sun's bubble isn't a clean line on a map. It's turbulent, uneven, and shaped like nothing scientists fully expected before the Voyagers got there. Today, both probes are still out there, still functioning, and still, barely, still listening and still speaking. But the machine that's making today's headlines is Voyager 1. Because Voyager 1 has spent 2026 fighting for its life in a way that reads less like a science story and more like a survival thriller. Here's the brutal math nobody escapes, not even a legendary spacecraft. Voyager 1 and Voyager 2 are both powered by something called a radioisotope thermoelectric generator, essentially a container of decaying plutonium-238, whose heat gets converted into electricity. There's no refueling this. There's no solar panel option. The sun is now just a bright star in Voyager's rear window, far too dim and distant to power anything. What you launched with in 1977 is what you're stuck with in 2026, and it decays a little every single year. Specifically, both Voyager spacecraft have been losing about 4 watts of usable power annually since they launched. 4 watts might sound small. Over almost 50 years, it isn't. It's the difference between a fully instrumented spacecraft and a machine now surviving on the barest fraction of what it once had. To manage that slow bleed, NASA's engineers have had to make a series of brutal choices, shutting down, one by one, systems that once made Voyager 1 a fully operational science laboratory. It's not glamorous. It's not the kind of message from an alien civilization story the internet loves to imagine. It's something quieter and, honestly, more human. A team of engineers, many of whom weren't even born when this spacecraft launched, carefully rationing electricity on a machine older than most of them, trying to squeeze out one more year, one more month, one more transmission. And that transmission, the one making news right now, isn't a discovery of alien life. It's not a hidden message. It's something more grounded and in some ways more remarkable. It's proof of life. A signal confirming that even now, even out here, past every planet, past every known boundary of the solar system, in temperatures and distances that would have been pure science fiction to the engineers who built it, Voyager 1 is still doing its job, still measuring, still listening, still reaching back across a light day of silence to tell us, I'm still here. That single fact, a 50-year-old machine still speaking to us from beyond the edge of the solar system, is the headline. Everything else is context. And the context, as you're about to hear, is a race against time that's playing out in 2026, right now, in real time. Here's where the story turns from incredible survivor into high-stakes gamble. Voyager 1 launched with 10 scientific instruments built to study Jupiter and Saturn up close during flybys that were over within a matter of years. Nobody in 1977 designed those instruments to still be running half a century later, in a region of space nobody even knew existed at the time. And yet, for decades, most of them kept working. A testament to the almost obsessive over-engineering of the era. But attrition has a way of catching up. On February 25th, 2025, NASA made the call to switch off Voyager 1's cosmic ray subsystem, an instrument that had been quietly measuring cosmic radiation since before some of its current mission engineers were born. It wasn't broken. It was simply too expensive in terms of power to keep running. Then, on April 17th, 2026, NASA pulled the plug on another one, the low-energy charged particles experiment known as LECP. This wasn't a minor instrument. LECP had been running almost continuously since 1977, nearly 49 years without failure, cycling through more than 8.5 million mechanical steps on a motor that was only tested on Earth to survive a quarter of that. It was LECP that helped scientists first detect the pressure fronts and shifting particle densities that told them Voyager had truly crossed out of the solar system's influence. It was one of the instruments that helped write the first chapter of the interstellar age. And on April 17th, mission engineers sent the command that shut it down. Stamatios Krimigis, the instrument's principal investigator at Johns Hopkins Applied Physics Laboratory, described what happened next in almost reverent terms. Even after they cut its supplemental heater to save power, even as its temperature plunged to nearly minus 62 degrees Celsius, deep into conditions the instrument was never rated for, the mechanism kept stepping. It kept trying to do its job in the freezing dark, long after any reasonable engineer would have expected it to fail. The stuff that dreams are made of, Krimigis called it, but sentiment doesn't pay the power bill. LECP is now offline. Only 2 of Voyager 1's original 10 instruments remain active. The magnetometer, which measures the strength and direction of magnetic fields in interstellar space, and the plasma wave subsystem, which detects the density and movement of ionized gas around the spacecraft, essentially listening to the weather of the space between stars. Everything else has gone dark, sacrificed to keep the spacecraft's heaters running and its transmitter alive. This is where NASA's engineers in 2026 decided that simply managing decline wasn't enough. They needed something bolder. They needed what they've internally nicknamed the Big Bang. The Big Bang isn't a bomb, and it isn't a metaphor for destruction. It's the opposite. It's a coordinated, all-at-once electrical maneuver, swapping a whole cluster of powered devices simultaneously, replacing higher power components with lower power alternatives, all in a single tightly choreographed sequence, in order to free up just enough electricity to keep the spacecraft's essential heaters running for years longer than current projections allow. If it works, it buys Voyager time, real time, potentially enough to push its operational there's a real chance engineers could switch LECP back on. NASA deliberately left a small half-watt motor inside the instrument alive, spinning uselessly for now, purely so that door stays open, because this maneuver is high risk turning off. Turning off systems that keep a 50-year-old spacecraft warm in a region of space with no possibility of a repair crew, ever under any circumstances. NASA chose not to gamble with Voyager 1 first. Instead, they tested it on Voyager 2, which sits slightly closer to Earth and has a small power cushion. Voyager 1 no longer has. Those tests were carried out in May and June of 2026. Only if that trial run succeeded would engineers dare attempt the same maneuver on Voyager 1, a spacecraft with far less margin for error, sitting even further from any possibility of help. That attempt was scheduled for no sooner than July 2026, which means that right now, as this very transmission from beyond the solar system is being studied by scientists on Earth, the Voyager team is in the middle of one of the most consequential engineering gambles of the spacecraft's entire 50-year history. A single misstep in this sequence, one command sent slightly wrong, one component that doesn't respond the way 60-year-old engineering diagrams predict, could plunge the spacecraft into cold it cannot recover from. Voyager mission manager Kareem Badarudin summed up the team's mindset simply. They remain focused on keeping both Voyagers going for as long as humanly and mechanically possible. Understand what's actually happening here. This is not routine spacecraft maintenance. This is a team of engineers working with documentation and hardware architecture from the 1970s, attempting real-time electrical surgery on a patient they can't touch, can't see, and can only speak to with a 2-day delay between question and answer. If they get it right, Voyager 1 might sing past its 50th anniversary. A milestone even its own mission managers openly admit is the personal dream driving this entire effort. If they get it wrong, the silence could come far sooner than anyone wants to say out loud. Every new signal Voyager 1 sends home right now carries the weight of that uncertainty. Every transmission might be routine, or it might be the last one before the cold winds. That tension, hope wrapped inside a countdown, is exactly why this old news spacecraft is back in now. Headlines in 2026, because for the first time in years, we're not just watching Voyager 1 survive. We're watching humanity actively fight in real time across a light day of empty space to keep it alive. To understand why this matters, why an aging, half-blind machine sending faint radio whispers from the edge of nothing still commands global attention in 2026, you have to go back to what Voyager 1 was actually built to carry. Bolted to the side of the spacecraft is a golden record-shaped disk. Not metaphorically golden, actually gold-plated copper, engineered to survive essentially forever in the vacuum of space, protected from erosion, radiation, and the slow chemical decay that eats away at everything on Earth. It's called the Golden Record. And it was assembled by a team led by the astronomer and science communicator Carl Sagan, working against a brutally tight deadline in 1977. On it, sounds of Earth, whale song, thunder, wind, laughter, a baby crying, music spanning cultures and centuries, Bach, Chuck Berry, traditional music from dozens of countries, spoken greetings. In 55 languages, photographs encoded onto the disk showing human anatomy, DNA, city streets, families, farms, mathematics, instructions etched in symbols meant to be decipherable without knowledge of any human language, showing how to build a device capable of playing the record back. And a diagram pinpointing the location of Earth relative to a set of pulsars, a kind of galactic return address. The odds that anything or anyone will ever actually find that record and know what to do with it are vanishingly small. Voyager 1 isn't headed toward any particular star system. In roughly 40,000 years, it will pass within a couple of light years of a star called Gliese 445. Not a flyby, not a rendezvous, just a distant, silent passing in the dark with nobody there to notice. And yet, the record was never really about reaching an audience out there. It was about who we were, choosing deliberately to leave something of ourselves behind. A species reaching past its own boundaries, not out of necessity, but out of curiosity and a kind of stubborn hope. That same spirit produced perhaps the single most famous image in the history of spaceflight. In 1990, with Voyager 1 already well past Saturn and its primary mission long complete, Carl Sagan convinced NASA to do something engineers were nervous about. Turn the spacecraft's camera around back toward the inner solar system and take one last photograph of home. From roughly 6 billion kilometers away, Voyager 1 captured Earth as a single, fragile point of light, less than a pixel caught in a stray beam of scattered sunlight. It became known as the pale blue dot. Sagan's words about that photograph have outlived nearly everyone who first heard them. That this pixel is where everyone you have ever loved, every human who ever lived, every war and empire and civilization, played out on a mote of dust suspended in a sunbeam. After that photograph was taken, Voyager 1's cameras were deliberately powered down. There was no more power to spare for imaging. It was, quite literally, the last look back. Everything since then, every year of the 21st century that Voyager 1 has survived, has been extra. Bonus time. A mission designed for 5 years, still delivering data 49 years later, has already outlived its own blueprint by a factor of 10. Along the way, it has done more than just survive. In 2017, mission engineers faced a genuine crisis. The primary thrusters Voyager 1 used to orient itself toward Earth were degrading, threatening to sever communication permanently. Rather than give up, the team dug up decades-old, essentially forgotten technical documentation, written in an era before most modern spacecraft engineering software existed, and successfully fired a set of backup thrusters that hadn't been used since 1980. Those thrusters worked. NASA called it a miracle save, and it bought Voyager 1 year of additional operational life. Then, in November 2023, the spacecraft suffered arguably its most serious crisis yet. A corrupted memory chip caused Voyager 1 to start transmitting complete gibberish, readable radio signal but data that made no coherent sense, like a person speaking fluently in a language that doesn't exist. For months, the spacecraft was technically alive but functionally mute, its actual condition and location a mystery to the very people who built it. Engineers spent nearly half a year working across that same brutal light-day communication delay, testing single hypotheses that each took 2 days just to confirm or rule out, before finally isolating the fault and rerouting the corrupted memory segment to working hardware elsewhere on the spacecraft. By April 2024, Voyager 1 was speaking clearly again. By June 2024, it had resumed full science operations across all 4 instruments that remained active at the time. This is the pattern that defines Voyager 1's entire history, and it's the pattern playing out again right now with the Big Bang maneuver, crisis, improvisation, survival, against odds that should have ended this mission decades ago. Every single time engineers have declared this spacecraft was reaching its limit, it has answered back, faintly, delayed by a full day each way, but unmistakably with more data. That's the story behind today's transmission. It's not an isolated headline. It's the latest chapter in 50 years of a machine, and the humans who refuse to let it go quiet, doing the impossible one more time. Here's the part nobody wants to say directly, but everybody involved in this mission already knows. Voyager 1. That sometime in the 2030s, the spacecraft's remaining power will finally drop below the threshold needed to operate even its last instruments. When that happens, there is no fix, no maneuver, no Big Bang clever enough to reverse it. The plutonium will keep decaying, the watts will keep bleeding away. And at some point, for the first time since 1977, Voyager 1 will go completely, permanently silent. But silent doesn't mean gone. It means something stranger. Voyager 1 will keep moving. It will keep climbing outward, faster than any other human-made object forever, or at least for as long as forever means anything in a universe with an actual expiration date. It's not orbiting the sun. It's not coming back. It has already technically escaped the sun's gravitational grip entirely, long after every human being currently alive has died, long after the country that built it has changed beyond recognition, long after the very language on this transmission has evolved into something unrecognizable. Voyager 1 will still be out there, a cold, dark, silent shape drifting through the space between stars, carrying a golden record that nobody, perhaps ever, will play. That's not a tragedy. That's arguably the most human thing our species has ever built. Think about the timeline for a moment, laid out honestly, in full. September 1977, launch. 2012, crosses into interstellar space, the first human object to do so. 2023, nearly lost to a corrupted memory chip, silent for months. 2024, reborn, speaking again. 2025 and 2026, instrument after instrument sacrificed. Power rationed down to the barest essentials, while engineers gamble everything on a maneuver nicknamed the Big Bang to buy a few more years. November 2026. Mere months from now, Voyager 1 crosses the 1 light day threshold, a distance so vast that a hello and a we hear you back take 2 full days round trip. Sometime in the 2030s, silence, permanent and final, but not an ending, a continuation forever into the dark. This spacecraft has already outlived the engineers who insisted, back in 1977, that they weren't designing it to last 30 or 40 years. They were designing it not to fail. 50 years later, that distinction has become the entire story. It hasn't lasted by luck. It has lasted because at every single failure point, a dying thruster, a corrupted memory bank, a power budget stretched past reasonable limits, a team of human beings on a small blue dot 6 billion kilometers behind it, refuse to let it stop talking. And that's really what today's transmission is about. It's not really about the specific data, the magnetic field readings, the plasma wave measurements, the faint electronic whisper of a region of space human beings will likely never physically visit for centuries, if ever. It's about the fact that the conversation is still happening at all. A signal sent from a point so remote it takes light itself a full day to cross the gap, arriving here on Earth and being received, decoded, and understood by scientists who weren't even born when the spacecraft that sent it left the launch pad. Every additional transmission Voyager 1 sends home is borrowed time, purchased through decades of stubborn engineering, careful power rationing, and, this year, specifically, a genuinely audacious gamble that mission engineers are running. Right now, in real time, on hardware from the disco era, sitting in a region of space colder and darker than almost anything human beings have direct experience of. So, when you hear that Voyager 1 just transmitted data from beyond the solar system, understand what that sentence actually contains. It contains 50 years of engineering. It contains a golden record nobody may ever hear. It contains a photograph of silence. It contains thrusters fired for the first time in over 40 years. It contains a team of scientists, right now in 2026, betting everything on a maneuver called the Big Bang, trying to squeeze a few more years of life out of a machine that was only ever supposed to last 5. And it contains this, the simple, defiant fact that somewhere out past the edge of everything familiar, past the last planet, past the boundary where the sun's influence finally gives way to the vast dark between stars, a 50-year-old spacecraft built by human hands is still speaking. We built something that could outlast us. And for now, for one more signal, one more transmission, one more whispered confirmation across 25 billion kilometers of silence, it still is. This is Voyager 1. It's still out there. And it's still talking.